Hi friend, welcome. Welcome to Dataplex. We share the value through the information intelligence. And today we are going to see the moon to Mars architecture from the NASA. NASA is designing a roadmap for the long-term exploration of the lunar surface and want to keep the first step on the red planet and the journey beyond, working with the so many partners in the industry, academia and international community. So friend, what is a architecture moon to Mars? That's quite inspiring, quite interesting. So when most think of the architecture, they envision about the skyscraper, cantilever homes or the marble museum. But in this case of the architecture moon to Mars isn't the build environment. It is not a mission, a manifest, or a set of requirements. Instead, NASA's Moon to Mars architecture defines the elements needed for long term human led scientific discovery in deep space. Deep space, that's important. NASA's architecture approach distills agency developed objectives into operational capabilities and elements that support science and exploration goals. Working with the experts across the agency, industry, academia, and international community, NASA continuously evolving the blueprint for the crewed exploration, setting humanity on a path to the moon, Mars, and beyond. So, friend, let's have a look on the executive overview of this moon to Mars architecture. What exactly it is, what is the definition of it, what they are doing in it. These executive statements, moon to Mars architecture. So, NASA is leading a campaign of human exploration, science, and discovery that begins in lunar space and journeys on Mars. This document summarizes the agency's recent body of planning focusing on work performed during the 2023 architecture concept review cycle. So, in this particular executive review, index and introduction, what is the architecture process, what are the objectives, overview, what are the architecture segments, what are the sub architectures, architecture elements, white papers, and what is the forward exploration roadmap. So, basically, friend, it is the integration of the science, inspiration, and national posture. So, in the science, it is a physical, heliophysics, astrophysics, biological, planetary, human research. In the inspiration, it is the STEM, the science, technology, engineering, and maths. Preserve the humanity. And in the national posture, it is the international relationship, global influence. So, what is this particular architecture process? The key terms in this are architecture. This is the unified structure that defines a system, providing rules, guidelines, constraints for constituent parts and establishing how they fit and work together. The characteristics and the needs, the features, activities, capabilities necessary to safety and satisfy goals and objectives. What are the use cases for this particular exploration and operation that would be executed to meet the desired characteristics and needs? Function. What are the functions or activities should be done by the people? Element. What are the elements included in this particular exploration from starting from Earth to Moon to Mars? Sub-architecture. A group of tightly coupled elements, functions, and capabilities that work together to accomplish one or more objectives. What are the segments in it? A portion of the architecture that integrates the sub-architectures progressively increases the complexity and objective satisfaction. So basically, the architecture concept review was done in the 2023 November with the NASA's leadership at the NASA Kennedy Space Center in Florida. Attendees included a representative of all the NASA centers, leaders from all the NASA mission, directors, various technical authorities, and other stakeholders across the agency. So basically, in this architecture, it is the combination of the different things. Design reference or the mission or concept ops. We have this DevOps for the software development, but as this is the concept moon to Mars architecture, it's called concept operations. Elements and the requirements. What are the requirements for this particular operations? What are the use cases? What will be the use cases starting from here to go Mars and come back? All those things. Operations executed to produce the desired needs and the characteristics. Functions. Actions and architecture performed to complete the desired use cases. Characteristics needs. Feature activities need to be in this case for achieving the goals and objectives and goals. Leadership define the blueprint vision for the moon to Mars endeavor and discovery of the deep space going ahead in the future. So, selecting the right tools. The very important to select for any architecture system design the right tools, right strategy, right network, right architecture. It makes the architecture sustainable more going forward. So the moon to Mars objectives. What are these objectives? Okay. So the NASA's moon to Mars objectives seek to expand the humanity frontiers in space science and exploration. The objective fall into the goals are as below, friends. What are those? Lunar and planetary science. In this category, answer the questions about the formation of our solar system, the geology and the chemistry of planetary bodies, and the origins of life. Applied science. Conduct the science utilizing integrated human and robotic techniques to inform the design of exploration systems. Heliophysics. Advance our study of the sun and our ability to observe, model, and predict space weather. Lunar infrastructure. Create a framework for government, industry, academia, and industry international partners to participate in a robust lunar economy and facilitate science. Human and biological science. Grow our understanding of how the lunar, Martian, and deep space environments affect living things. Mars infrastructure. Develop the power, communications, navigation, and resources utilization capabilities to support the initial human Mars exploration. Physics and physical science. Investigate space, time, and matter in the unique environments of the moon, Mars, and deep space. Transportation habitation. Create systems necessary for humans to travel to the moon and Mars, live and work there, and return to Earth safely. Science enabling. Develop integrated human and robotic techniques that addresses high priority scientific questions around and on the moon and on the Mars. Operations. Conduct crewed missions to globally build technologies and capabilities to live and work on the planetary surface other than Earth. So these were the 10 objectives of the moon to Mars exploration. So basically now these objectives and goals are divided as per the pages. In that case, use cases define. For example, we will take the one use case. Crew and supporting systems transit from Earth to cislunar space. This is a use case. In that functions, what are the functions included? Provide ground services on Earth, stack and integrate system on Earth, manage consumables and propellant, enable vehicle launch, allow multiple launch attempts, enable abort to safety, transport crew and associated cargo from Earth to cislunar space to support short duration days to weeks missions, distribute power to utilization payloads in cislunar space, transport crew and associated cargo from Earth to cislunar space to support mid duration month to extend plus year durations. So these are use cases and the functions defined in it and some characteristic needs. For example, what is the characteristics? Provide capabilities to transport crew and system from Earth to cislunar space. So friends, in this architecture, what is very important? How the human can go to lunar and how it can come back safely. So this includes the inaugural Artemis missions, which return humanity to the moon for the first time since Apollo's missions of the 1960 and 70. This segment will demonstrate and validate the core systems and capabilities for the moon to Mars effect. Foundational exploration, sustained lunar exploration and human to Mars. So basically from the 1960, whatever this search and exploration started to go advance in it for day. So what are the sub architectures in this particular moon to Mars exploration? So first is communication, navigation, positioning and timing system. This is very important because without communication nothing will happen in the space. So under this will enable the transmission and reception of the data, determination of the location and orientation and acquisition of precise time. If we are on the Earth, we know that what is our GPS location, but if we are in this space, how do we confirm where is the coordinate right now, where is the position? That's very important. So this is one of the important element. Number 2, human systems. Execute human and robotic missions together. This includes the crew, ground personnel and supporting systems. Number 3 is mobility system. In that, move the crew and cargo around the lunar and Martian surface. Number 4 is transportation systems. Convey crew and cargo to and from Earth to the moon and Mars. Number 6 here we say data systems and management. Transfer, distribute, receive, validate, secure, decode, format, compile and process data and commands. Infrastructure support. In this includes the facilities, systems, operations, planning and control, equipment and services needed on Earth, in space and on planetary surface. Habitation systems. Ensure the health and the performance of astronaut in controlled environment safely and betterly. Logistics systems. Package, handle, transport, stage, store, track and transfer atoms and cargo. Power systems. Generate, store, condition and distribute the electricity for architectural elements. Utilization systems. Enable science and technology demonstrations. In situ resource utilization systems. Extract resources in space or on the moon or Mars to generate products. Autonomous systems and robotics. Employ software and hardware to assist crew and operate during uncrewed periods. Autonomous systems are very important. If anything happens, how those autonomous systems should take control and should safely act and behave. So there were 2023 there are so many white papers. One white paper was published on surface extravehicular activity architectural drivers. So this tells when humans return to the moon, they won't simply land, they will explore the lunar surface during the extravehicular activities and spacewalks. NASA and its partners will need to address the unique challenges of walking on the moon. The lessons learned on the lunar surface will directly influence plans for crewed Mars missions. Lunar communications and navigation architecture. NASA's return to the moon will require reliable communication services and accurate navigation data. A network of ground stations, space relay satellites, and surface to surface communications equipment provided by NASA, industry, and international partners will keep Artemis astronauts connected with the Earth. Lunar logistics drivers and needs. To support the crewed missions, the missions need numerous logistic items, the equipment and supplies necessary to sustain life, maintain systems, and conduct science supplied to the lunar surface. The composition and amount of these items vary significantly based on the mission requirements. Lunar site selection. Exactly where the Artemis mission land when humans return to the moon will depend on wide variety of the factors: surface condition, science objectives, and lighting environment, communication availability, system capability, and more can affect landing site selection. Safe and precise landing at lunar sites. Precision lunar landings will become increasingly important as space agencies and private companies explore more of the moon. More precise landings enhance crew safety, minimize site contamination, and enable missions to reach specific scientifically significant site. Analytical capabilities is very important. Samples collected on the lunar surface may be analyzed by the science instruments launched to the moons or laboratories on the Earth. In situ analysis is limited by the capabilities of instruments that can be launched to the moon, whereas samples returned to the Earth can be benefit from the more refined analysis. However, returning pristine samples, those kept in the environment in which they were collected, to the present technological challenges. So, in this friends, the many more things are there, possibilities, because you also need to consider different factors when designing this particular architecture definition. Mars mission, about considerations, Mars communication disruption and delay, Mars surface power generation. Okay, these all the things need to be considered. Round trip to Mars mission. So this is how about the executive particular reports. So they had all the architecture, functions, use cases, scenarios, everything in it. So this architecture definition includes the overall information about this moon to Mars exploration. So friend, this was the short story about moon to Mars exploration architecture definition, and this exploration will help the humanity for going ahead in the deep space. So particularly in this architectural definitions, what are the things discussed or analyzed or put? One, what is the purpose of this particular mission, scope, content to the structure, content outside and scope, architecture methodology, objective decomposition process, architecture framework, architecture definition process. In the architecture decomposition, exploration strategy, why to explore, science, national posture and inspiration, lunar architecture strategic assessment, key lunar decision drivers, unique considerations for the moon, Mars architecture strategic assessment, key Mars decision drivers and unique considerations for Mars, decomposition of the objectives, lunar planetary science, heliophysics science, human and biological science, physics and physical science, science enabling applied sciences, lunar infrastructure, Mars infrastructure, transportation and habitation operations. Moon to Mars architecture, human lunar return segment. What are the summary objectives, use cases and functions needed for it, reference mission and the concept of operations. Why do you need the concept of operations? The important thing, before doing anything in reality. You can create the concept of operations, what can happen, to be scenarios considering all end-to-end process. What can happen if you want to go to the Mars and the moon and come back? In this whole concept of the scenarios, what are the things can happen, need to happen, and make to happen? Okay, so for this all we need to see the architecture elements. It is the people, it is the process, it is the data, the communication, and this all autonomous things in it. So for the foundational exploration segment, use cases and functions to be defined, summary and objectives, reference mission concept, sustained lunar evaluation segments, human to Mars segment, and the assessment of these things done. International collaboration, how it can be done, industry collaboration, crew return, crew times, maintainability and reuse, responsibility, use, interoperability, leverage the low Earth orbit, commerce and the space development. So friends, this architecture is very important. This is a very high level unifying structure that defines the system. It provides a set of rules, guidelines, and constraints that define a cohesive and coherent structure consisting of constituent parts, relationship, and connections that establish how those parts fit and work together. This engineering handbook is essential to capture the broad range of systems, programs, and projects supporting the human exploration of the moon, Mars, and beyond. Although this definition is typically used for a single program construct rather than a multi decadal moon to Mars human exploration architectures. The purpose: an integrated architecture creates many opportunities to execute the ambitious moon to Mars efforts. NASA addresses this in its moon to Mars strategy and objectives development document. So, the primary purpose of the architecture definition document ADD is to capture the methodology, organization, decomposition necessary to translate the broad objectives outlined in the moon to Mars strategy into functions and use cases that can be allocated and implemented across programs and projects. Inherent to this process will be need to communicate the long-term vision, maintain traceability to responsible parties, and iterate on architectural implementation as innovations and solutions develop. This document will be updated and improved in conjunction with architecture concept review, which will be held annually to get buy-in and input from across the agency on the human exploration architecture. The annual technologies and the new partnership, whether they are the industry, the US government and international agencies and academia. So what is the scope? The scope of this document is to capture the programs, projects, systems and contributors that enable the human exploration of the moon, Mars and beyond. The agency level moon to Mars strategy agency level moon to Mars strategy, the combined objectives that may be satisfied through the human robotic joint. So basically, what are these in the human exploration moon to Mars architecture? What are the very key element? Number one is human systems. It is human. Number two is robotic assistance in that. Number three, what are the future objects can be included in that? The communication, data, everything, all those things will come. Characteristics, needs, objectives, goals. This all the architecture, because if you are exploring the beyond the earth, there are so many factors in it: transportation, habitation, operations, infrastructure, science and many things. So this is the very moon to Mars architecture definition, the short story about it. If you want to know more, you can go and check visualization of the utilization areas. Okay, how we can utilize this planetary science study, heliophysics, astrophysics in the scientific research, technology test and validation, industrialization. It can be used. These all things. So this why we go. What are the six questions for any architecture, design or decomposition? Number one, why we go? Why we want to go? Number two, who we send on the Mars and Moon? Number three, what we do if we go there? Number four, where we will go, where we will land on the Moon and Mars? Number five, when we go, what is timeline? And number six is how we go. So these six questions are very, very fundamental and very important for this Moon to Mars human exploration project and architecture definition. If we consider these six questions and try to answer, then whole architecture definition will help to support to achieve the objectives defined this rate. And most important, what is the value out of it? The three pillars of the exploration from the NASA Moon to Mars strategy, objective development. What is the value actually? Value is for the science, for the human exploration, inspiration for the humans beyond the earth. So when we will let us see the answers. Okay, these six questions we saw for this architecture, but what are the answers at the top level? When will we achieve lunar objectives? Okay, multi-decadal campaign. It's not the one decade. Multi decades will need. Maybe by the 2050 we can able to do the better progress, but this is start. Support annual cadence of the crewed missions, development of permanent infrastructure, expansion of economic sphere to the moon. What foundation capabilities are needed? Long duration microgravity systems, partial gravity destination platforms, low Earth orbit assets and infrastructure. Where should systems be? Ensure access to lunar South Pole capability for non-polar sorties. Who does this approach include? NASA, industries, industrial partners, academia and public. How will we get there and return? Lunar microgravity staging operations in NRHO, Earth, NRHO, lunar surface and surface mobility. So the lunar architecture, why explore science, understand the universe, direct observations, in the inspiration, Artemis generation, overcome challenges, succeed with hard work, national posture, enrich the lives on the earth, technology development and international partnership. So friend, these were the exploration things about Moon to Mars exploration. It is huge visionary document inspiring strategy and architecture. That's very cool to see. One example, let us say 850 days Earth, Mars, Earth trajectory. It is very important to understand how we are gonna make trip to Mars, okay, and come back from it, because everything is moving, nothing is stable, nothing is at one position. So this timing and matching of this travel is very, very important. So this was just overview and overall Moon to Mars exploration, friends. We will bring small details later on it. Thank you very much for your time. This moon to Mars, I believe it's very inspiring, very interesting. The reason because it is exploring beyond the Earth in this deep space and going beyond. So, friend, this is what we saw: the moon to Mars architecture, system engineering analysis, and the exploration beyond, friends. Thank you very much for listening. Your answers will be interesting too. No, friends, what do you think about this exploration and your comments?